In this third session, modulation chapter, the student will be able to know what is modulation, need for modulation. Before going to that, why low frequency signal can travel long distances? Low frequency signal, that is audio signal, converted into electrical signal cannot be sent directly over the air for long distances. The energy of the wave is directly proportional to its frequency. At audio or low frequencies, the signal power is very small and the radiation is not practicable due to the attenuation. The radiation of electrical signal for long distances is possible only at high frequencies. Hence, long distance transmissions, low frequency signal is to be changed into high frequency signal. This is called modulation. Once again, the definition of modulation. Modulation may be defined as process by which some characteristics of signal known as carrier is varied in accordance with the instantaneous value of the another signal called the modulating signal. If a person throws a paper directly to the long distance, that is 10 meters, it does not reach like this. If we surround the ball to the paper like this and throw to a 10 meter distance, it reaches to the destination. Similarly, another example is person by a walk cannot reach the college within a time for a long distance. But if a carrier, that is bus carrier or auto or another vehicle, whatever it may be, we can take and reach the destination easily at college. That is the carrier. Carrier means just like our carrier signal, and person means persons means signals. As shown in the figure, person means signal and the bus means bus carrier, that is carrier signal. Both are mixed together to reach the destination. The person cannot reach the college within a time which is at long distance. That is, low frequency signal cannot travel long distances. To reach the college at a long distances within a time, person should go by bus because bus travels at high speed than walk. High frequency signals have high energy to radiate long distances within a short period. The signal containing information to be transmitted is called modulating signals or baseband signals. The signals which results from the process of modulation is known as modulated signal. If the carrier waveform is continuous in nature, then the modulation process is called continuous wave modulation. Amplitude modulation and angle modulations are two techniques. So, modulation means it is the process of varying some characteristics of high frequency signal in accordance with the instantaneous value of the low frequency signal. The characteristics may be amplitude, frequency or phase. Depending upon the characteristics, the modulations are classified. Need for modulation. Modulation technique is necessary in transmission of signals for long distances. The one, reduce the height of antenna. Second one, avoiding mixing of signals. Increase the range of communication. Allows multiplexing of signals. Allows adjustments in the bandwidth. Improves quality of reception. These are the need for modulation technique. Stability of the antenna or reduce the height of the antenna, that is, the minimum height of antenna is lambda by 4, where lambda is wavelength. Lambda is equal to c by f, where c is the velocity of the light and f is the frequency. F is equal to 15 kilohertz. Height of antenna is equal to c by f into 4, that is equal to 5000 meters. This height of a vertical antenna is unpracticable. For f is equal to 1 megahertz height of an antenna, that is equal to c by f into 4, that is equal to 75 meters. This height of antenna is practicable. Practicability of the antenna or reduce the height of the antenna, that is the minimum height of antenna is lambda by 4, where lambda is wavelength. Lambda is equal to c by f, where c is the velocity of the light and f is the frequency. F is equal to 15 kilohertz. Height of antenna is equal to c by f into 4, that is equal to 5000 meters. This height of a vertical antenna is unpracticable. For f is equal to 1 megahertz height of an antenna, that is equal to c by f into 4, that is equal to 75 meters. This height of antenna is practicable. Avoids mixing of signals. In this case, as shown in the diagram, signal 1, signal 2, signal 3, 20 kilohertz and 20 kilohertz signal, channel 1, channel 2, channel 3, bandwidth S, it contains bandwidth S. Signal 1 modulated with a carrier of 100 kilohertz, signal 2 with 200 kilohertz, signal 3 with 300 kilohertz. Frequency radiation is poor and signal get attenuated. Modulation increases the frequency of the signal and thus increases the distance of communication. Multiplexing of signals. Multiplexing means transmission of two or more signals simultaneously over the channel without reference. Modulation permits this type of multiplexing. For example, TV channels operated simultaneously, radio stations broadcasting signals simultaneously. Allows adjustments in the bandwidth. Bandwidth of a modulated signal may be made similar or longer than the original signal. Signal to noise ratio, which is function of bandwidth, can be improved by controlling bandwidth at the modulated signal. Improve quality reception. Using modulation techniques such as FM or PCM reduces the effect of noise to great extent. Reduce of noise improves quality of reception. About the definition of modulation and the need for modulation. Thank you.